Alright, so this question is asking us to find the gradient of the normal, which is this line here. To do that, we can get supplementary angles. 120 give us 60, because 180 minus 120 is 60. Next, we need to find out gradient, which is rise over run. So, rise over run is the same as opposite over adjacent in this case, which means we have to use tan. So let's do tan 60, which would get us square root of 3. Next, we need to use some logic here. We could say since normal is monotonically decreasing, therefore gradient is negative. Therefore gradient of normal is negative square root of 3. Okay, that's one way to do it. If you know what you're actually doing, you could just get tan 120, which would get us negative square root of 3. Because using tan on the angle on the right hand side of the line would always give us the gradient. So that's the fastest way to do it. Alright, next it wants us to find values of a and b. That's a big hint that we're going to have to do simultaneous equations somewhere, because we're solving for two values. Another hint is word hence. That means we'll have to use the answer to our previous question to help us solve this. So where do our two equations come from? Well, we already have an equation here, which is our function, y equals square root of ax minus b. Subbing in the values of square root of 3 and 4, because those are our coordinates. We can get square root of 3 equals square root of 4a minus b. Next, we can go further. We can square both sides to get 3 equals 4a minus b. And that gives us our first equation. For the second equation, we need to consider our answer from the previous question, which was the gradient of the normal. Now, how do we find the gradient of a tangent from the gradient of a normal? That's pretty simple. It's just a negative reciprocal. So that would be negative 1 over negative square root of 3, which is 1 over square root of 3, which is our gradient of tangent. Once we have that, we can go ahead and derive the equation. Give us half because of half, and inside the square root we have ax minus b. Differentiating that, we get just a. And lastly, we rewrite ax minus b to the power of half minus 1, which is negative half. Now, replacing our values, we have our tangent here, and x would be 4, because that's what the value we were using. Rewriting that, we can get a over 2 4a minus b. Now that we have that, we can sub in equations into each other. So I'm going to use b in this example. B equals 4a minus 3. If we sub that into our second equation, it will get for a minus 3, which would get us a over 2 square root of 3, because the 4a's cancel out. Now we can solve for a, pretty simple. Multiply both sides by 2 square root of 3. We get 2 square root of 3 over square root of 3. These cancel out, a equals 2. Right, now we can sub that back into our first equation. So b equals 8 minus 3. B equals 5. And that's how we get both values.